So in this video, we are going to solve a problem from exercise 8.4, and we are going to look at question number 3. Now the question number 3 reads evaluate. So we have to evaluate this expression, and there is another second expression here. But currently we'll start with the first expression that is given to us. Let's read the expression. It's sine square 63 plus sine square 27, the whole divided by cos square 17 plus cos square 73. Now we have to evaluate this expression. Now the first thing we notice, whenever you are given such numbers, okay, such numbers in your expression with the trigonometric identities, you should always see if their summation is 90 degree. Okay, now here we can clearly see, let's get the highlighter. Let me try to zoom in. 63 plus 27 is equal to 90. Okay, similarly 17 plus 73 is equal to 90. So the summation of these two angles, okay, these two angles is equal to 90 degree, which means we are going to use the complementary angle property for trigonometric identities. Okay, and what is that property? Let me just quickly write it down for the sake of reference. So basically, sine of theta is equal to cos of 90 minus theta. Okay, and similarly we have cos of theta is equal to sine of 90 minus theta. This is the complementary angle property for the trigonometric ratios sine and cos. Since we just have sine and cos here, I have noted down only sine and cos, but the same concept exists for tan and cot and for sec and cosec, these pair of trigonometric ratios. Okay, so since these numbers have summation equal to 90 degree, we are going to use this property. Now I'm going to start with the numerator first. So let me write here numerator. Yes, numerator is equal to what? Sine square 63 degree plus sine square 27 degree. Okay, let's write it properly. 27 degree. Okay, now this is equal to, so first of all, this is equal to sine 63. Let me try to zoom in. This is equal to sine 63 the whole square plus sine 27. Okay, the whole square. Now this sine 63, let me use the highlighter. This sine 63, I am going to use this complementary angle property. I am going to convert it into cos. Just this one single expression, not this one. Okay, so let me come to, okay, let's erase this. Let me come below. So that is equal to sine 63 can be written as cos of 90 minus 63. Okay, so sine 63 can be written as cos of 90 minus 63. Sine theta can be written as cos of 90 minus theta. That is equal to plus, this will be as it is sine 27 the whole square. Okay, now this is equal to, let's try to evaluate this expression. Okay, I'm going to evaluate 90 minus 63, that is equal to 27. So cos of 27 the whole square, and this is going to be equal to plus sine of 27 the whole square. And thus, as you can see, we have got this as equal to a trigonometric identity. So I'm just going to mention the trigonometric identity here, and that trigonometric identity is sine square theta. Okay, sine square theta plus cos square theta is equal to 1. Okay, so in this expression, theta is equal to 27. Doesn't matter. Sine square theta plus cos square theta will be equal to 1. So thus this numerator, okay, we were trying to evaluate the numerator, so the numerator has been evaluated to 1. So I'm going to quickly write it here. This is equal to 1 divided by, now we have to check the denominator. So again, for denominator, let's come to this side. Okay, so denominator, what is the denominator? It is cos square 17 plus cos square 73 plus cos square 73. Okay, let me draw a line here. Yeah, now once again, these two are summation of 90 degree. So I'm going to convert one term. Let's assume the first one. I'm going to convert this first term into sine. And how is that possible? Using this property. Okay, so let's go ahead. Okay, let me try to zoom in. Yes. So this is a denominator that will be equal to, so I'm going to write it first, cos 17 the whole square plus cos of 73 the whole square. Now convert this into sine. So this is going to be sine of 90 minus 17. Okay, and this whole square, don't forget the square, that is equal to cos of 73 the whole square. Okay, and now once again, what is this expression? Okay, what is 90 minus 17? That is equal to 73. So I'm going to write this sine of 73, then this whole square plus cos of 73 the whole square. And once again we get this trigonometric identity, sine theta square plus cos square theta, which is equal to 1. So this is also equal to 1. Okay, so our denominator, we were trying to evaluate the denominator. Our denominator has also come equal to 1. So let's come here. Yes, so denominator is also 1, numerator is also 1, and 1 divided by 1 is equal to 1. So our first expression that we were asked to evaluate, this first expression, let me use an eraser to get rid of this, that has been come equal to 1. Okay, so this is how you have solved the first problem. Now let's come to the second problem. Before we come to the second problem, let's try to clear this up. Okay, so this was our first problem and this was equal to 1. Now let's see what is the second problem. Let's get rid of this. Delete. Okay, now the second problem reads sine 25 into cos 65 plus cos 25 into sine 65. Now once again, if you look at these numbers, 25, 65, their summation is 90. Same goes with this, 25, 65, the summation is 90. So whenever the exact numbers are given in your angle, okay, this particular numbers are given in the angle, you just check if the sum is equal to 90. Whenever the sum is equal to 90, we can always use the complementary angle property. And once again, I'm just going to make a note of the complementary angle property of the trigonometric ratio. So we have yes, sine of theta as equal to cos of 90 minus theta. Okay, and we also have cos of theta as equal to sine of 90 minus theta. So we are going to use this property to do some convergence. So now in this particular example, I'm going to convert sine 25 to cos. So in fact, let me erase this so that I can use sine 25. I'm going to convert to cos, and here cos 25 I'm going to convert to sine. Okay, let's do it simultaneously. So sine 25 can be written as cos of, okay, that is equal to cos of 90 minus 25, right, into cos of 65 as it is, and plus this term. So cos of 25 is nothing but sine of 90 minus 25, okay, into sine of 65. Okay, so this is my first term I've written here, and this is my second term I've written it as it is. Now let's try to evaluate them. That is equal to, now, okay, let's use the highlighter. What is cos of 90 minus 25? That is equal to cos of 65 into cos of 65. Okay, plus as it is. And what is sine of 90 minus 25? That is again equal to sine of 65 into sine of 65 as it is. Okay, so very clearly we have got your cos 65 the whole square plus sine 65 the whole square, which is again equal to, now this is of the form of a trigonometric identity, sine square theta plus cos square theta is equal to 1. Here the value of theta is equal to 65. So this is going to get evaluated to 1. Okay, so once again we have this second expression which has also got evaluated to 1, and expression number 1 also got evaluated to 1. So I'm going to write here this is okay. I'm going to write that the second expression is also equal to 1.